Welcome to Fluid Mechanics and Hydraulic Machines Laboratory. Today we are going to conduct an experiment to determine the coefficient of discharge through a Venturimeter. Coefficient of discharge is the ratio of actual discharge to the theoretical discharge. Venturimeter is an instrument which is used to determine the rate of flow or discharge through a conduit section. Pipe is an example for the conduit section. Discharge has got three different components. The first one is convergence zone, and the second is the throat, and the third is the divergence zone. The angle in the convergence zone is between 15 to 20 degree, and the angle in the divergence zone is between 8 to 12 degree. A U-tube manometer will be connected between the convergence zone and the throat to measure the pressure difference between these two sections when the fluid is flowing through it. This is the experimental setup of the Venturimeter. Venturimeter has got three different sections. As we said, first is the convergent, second is the throat, and the third is the divergent section. The Venturimeter will be connected to a pipe through which the water will be pumped in, and at the outlet the pipe will be connected to a collecting tank of known area. The inlet and the throat section will be connected to U-tube manometer, which is filled with mercury to determine the pressure difference between the two sections when the fluid is flowing through it. During the experiment, make sure that the mercury levels in the right and left limb of the U-tube manometer are noted down. Switch on the pump and allow the water to flow through the Venturimeter. After a steady flow is seen in the Venturimeter, remove the air bubbles in the U-tube manometer. The air bubbles in the U-tube manometer will be removed by opening the valves and allowing it for few seconds and closing the valves. After a steady flow is seen through the Venturimeter, note down the pressure difference between the inlet and the throat in the U-tube manometer and note down the readings. After a steady flow is attained in the Venturimeter, close the outlet point and note down the time taken for a 10 cm raise of water in the collecting tank. Firstly, note down the diameter of the Venturimeter at inlet, which is given as 25 mm. In terms of meters, note down it. The diameter of the Venturimeter at the inlet is 25 mm and the diameter of Venturimeter at the throat is 12.5 mm. Therefore, calculate the area at the inlet and also calculate the area at the throat, which is taken as Finally, calculate the area of the collecting tank by note downing the breadth of the collecting tank and the length of the collecting tank. The breadth of the collecting tank is 0.3 meter and the length of the collecting tank is 0.3 meter. Therefore, area of the collecting tank is 0.09 meter square. The theoretical discharge in a Venturimeter is given by the formula Q theoretical is equal to A1 into A2 into square root of 2G into HV divided by A1 square minus A2 square, where A1 is the area at the inlet, which is given by 4.908 into 10 power minus 4 meter square. A2 is the area at the throat section, which is taken as 1.227 into 10 power minus 4 meter square. HV is the Venturi head, that means the pressure difference in the manometer between the inlet and the throat section in terms of meter of water. When the water is passed to the Venturimeter and when a steady flow is attained, note down the manometer reading in the left limb and the right limb. In the left limb, the manometer reading is 70 mm of mercury, and in the right limb, the manometer reading is 30 mm of mercury. Therefore, H2, that is in the left limb, will be in a negative, hence the total head in the U2 manometer becomes 100 mm of mercury, that means 0.1 meter of mercury. The head should be converted in terms of meter of water, which is given by H into Gm divided by Gp minus 1, where Gm is the specific gravity of the manometer liquid, Gp is the specific gravity of the pipe liquid. In the above experiment, the manometer liquid will be mercury, where the specific gravity is 13.6, and the pipe liquid is water, where the specific gravity is 1. When it is calculated, the head of the Venturimeter in terms of meter of water will be 1.26 meter of water. The actual discharge through a Venturimeter is given by the formula Q actual is equal to A into R divided by T, where A is the area of the collecting tank, which is taken as 0.09 meter square. R is the rise in water in the collecting tank, which is taken as 0.1 meter, and T is the time taken for the R, that is the time taken for 10 centimeter rise in the collecting tank. By the Q theoretical formula, for the first trial case, the actual discharge is taken as 6 into 10 power minus 4 meter cube per second, and by the formula for the theoretical discharge, it is taken as 6.302 into 10 power minus 4 meter cube per second for a 0.1 meter rise in the collecting tank, which is 15 seconds. Therefore, the coefficient of discharge is calculated by the formula CD is equal to Q actual by Q theoretical, where Q actual is the actual discharge and Q theoretical is the theoretical discharge, which gives as CD 0.95.